Well, good morning, everybody. Welcome to this Tailgate Talk. We're going to talk about, as we do every time we do these, waterworks, manufacturing, engineer standards, certification, construction, that type of thing. We consider ourselves the manufacturer of the best valves and hydrants under earth. We make a complete line of gate valves, butterfly valves, check valves, and fire hydrants. And we kind of want to have Tailgate Talk be your one-stop shop for any of your AVK questions. So in this episode, we're going to have Randy Looney, Mark Tompkins, John Wilbur, and myself. We're just going to talk about what we consider the main fire hydrant improvements to be. And Randy, welcome to this. And can you tell us a little bit about the number of improvements AVK's made since you began at AVK, and what it is you do and what your mission at AVK is?
Thanks, Kent. I am the Quality Control, Technical Services, and Engineering Manager for American AVK. It's my job to make sure that we provide a high-quality product to our customers, and along with John Wilbur, to design, engineer, and implement the quality improvements into our products. American AVK is certified to the ISO 9001 standard for a quality management system. This system has a requirement for continuous improvement. Part of this continuous improvement process includes customer comment reports that are submitted to our office by our AVK field sales reps. The customer comment reports are reviewed by our office staff each week, so we're able to consider suggestions for improvements from customers and also examine any problems customers are experiencing with our products. This is just one of the tools we use to listen to our customers in order to make changes and improvements. In the 39 years since AVK introduced the Series 27 dry barrel hydrant to North America, we have made almost 80 changes and improvements to the overall design. That said, one thing we always keep in mind is retrofitability. While not always possible, when we do make an improvement, we strive to make that change available as an upgrade to older AVK hydrants that are already in operation in the field.
Okay. Well, I'll move on to John Wilbur. And John, one of the things that I always find to be pretty fascinating is the work you've done with the AVK brake coupling, and a little bit about the difficulty you have every time you try to improve the brake coupling and why that would be. Can you kind of elaborate on that a little bit?
Yeah, sure. So first, let's talk about the stem coupler pins. The original stem coupler pin was a pin just about like this with a hole on both sides, and these clips are on both sides, and that made it a little bit more difficult to change out. And I'm going to go forward a couple of slides here. Our lower stem coupler pin, which attaches the main valve to the lower stem, used to be a split pin, which was hammered in and almost impossible to remove if you ever needed to change the main valve. And this is our old main valve design, by the way. So we currently use the same design for our lower stem connection that attaches the main valve as we do for the stem coupling right here. And this slide right here shows a pretty good iteration of all of our stem coupling designs. Our first stem coupling was a piece of 304 stainless steel tubing, which is a lot like this, with this knot down here that was designed to tear out when it was hit by a car. And then this is the second iteration of the coupling, which was a cast 304 stainless steel coupling, and we had troubles with it elongating under use. Now the UL standard requires that this thing be able to take 200 foot-pounds without any damage, and the hydrant still needs to be operable, and it passed that test. But it turns out that in the field, people sometimes put in quite a bit more than 200 foot-pounds. So the next iteration we came up with was this one right here in the center, in case you can't see my cursor when I'm pointing to stuff, which I can. It's made out of cast 431 stainless steel. It easily passed the 200 foot-pound test. It's designed to break in the middle of this groove right here, and it would break under a load of 300 to 350 foot-pounds. And if you may not know this, but a 200 foot-pound load on the operating nut equates to a 15,000 pound vertical load on the stem. So somebody's putting 300 foot-pounds on this, they're getting up above 20,000 pounds. And lo and behold, this coupling would break because people were trying to close a hydrant that maybe had a rock or something. They couldn't get it to close. So our last iteration is this one right here. This baby can take 400 to 450 foot-pounds without breaking. It's also got the same diameter pins that was used in all of these, so it's retrofittable. Since it can take such a high load, we had to go to a higher strength pin. These were 420 stainless steel.
And that's the one on the left.
The ones on the left were 420 stainless steel. The ones on the far, is it the left or the right? The one on the far right was 420. The one on the far left is our new design. It's 431 stainless steel pins. And this thing can take 30,000 foot-pounds without breaking. But if a Prius hits the hydrant at 30 miles an hour, it will break. So this has always been a very interesting design problem. And so far, this coupling we have here, which is the one on the far left, seems to be working very well. And I'm going to hand it off to you, Kent.
All right. I would agree. We actually have had some utilities that had their own specs for very heavy-duty couplings, and that coupling on the left is so strong that it's now the standard at all those locations. So, Mark, I guess we'll kind of turn it over to you, and you can talk about what you think your top 5 hydrant improvements would be and why, or your top ones.
Okay, thanks, Ken. I appreciate it. Yeah, we have a lot of improvements, but I think starting off, one of the nice ones I've seen is our stainless steel upper stem rod. Basically, in the past, the stem on the right, we used to have a regular carbon steel stem with a little copper sheath on top that just protects your O-rings. That was actually crimped into place. About 1998, we had an option where you could have a stainless steel upper stem, and then that became a standard feature in November about 2003. What we've done is we've done away with that little piece of copper that is crimped onto the upper stem. In the past, places that definitely had seasons, unlike Texas, places that actually had a winter and a summer, sometimes you'd get water behind it. It would expand and contract, cause it to crack. Sometimes it would damage the O-rings, be very hard for the hydrant to open or close. Or if you ever took the bonnet off, sometimes it would actually come off. But we've eliminated that need with our stainless steel upper stem. And again, as Randy had said earlier, the good thing is a lot of our parts are retrofittable. So you can take our brand new stainless steel stem and put it into any of our hydrants in the field. Subsequently, we've also, at the same time in November 2003, we also changed all of our extension stems to be stainless steel. So that's a great feature. The next feature, and sometimes it's the little things that matter. This is our rubber gasket, the gasket that fits on the barrel, the bonnet, extension kits, and now also into the lower shoe. A lot of our customers like it because it actually is a stainless steel insert, which just makes it for a lot easier assembly. It's less likely, even if you bend the gasket, it's very easy to reform it, put it back into place. It makes it very rigid, so if you have to turn the barrel or the bonnet, it's less likely to slip off as it would be, say, an O-ring or a smaller gasket. We basically had that in place since about 2005. The next feature I have, which has got to be the most important feature we have, is our one-piece main valve. As John showed earlier, this was our original main valve, which was our multi-piece main valve. And then in 1992, we actually went to a one-piece main valve, which is a ductile iron core encapsulated with EPDM rubber. The valve you see on the left was our first version of that. Again, makes for very easy maintenance, less parts to go wrong, one solid piece of ductile iron encapsulated with rubber. We changed that in about 1992. Now, subsequently, in July of 1997, we actually had what we call the HydroFlow main valve, which was the main valve on the right. That main valve was built to help if you had any situations that had slamming or chatter. This was the main valve for choice. Subsequently, in December of 2017, we decided to make that main valve our standard main valve for all of our fire hydrants. The nice thing about that main valve is if you have a rock or a pin or debris that gets into it and gets closed up against the main valve, if you have a dent in it, obviously, the hydrant will leak, water will pass. But if you swap it out, if the rubber hasn't been cut, in most cases, it actually will self-repair. I have a lot of cities, big cities that use the AVK hydrant, and what they do is they keep a shelf of all the older valves that they have. If they go out into the field, they have to swap a main valve out. They'll bring back the old one. They'll put it on the shelf. A week later, they'll go look and see. If it's just a dent, most of the time the dent will actually pop itself back out. It'll self-repair, and you can use that next time you go out into the field. The only time it won't self-repair if there's a cut in it. But we're so sure of our design in our one-piece main valve that we now have extended that to a 25-year warranty, and that took place November 2020. I think probably the next feature that I like to talk about would be our epoxy coated hydrant interior. All of our upper barrels, the bonnet and the body, is actually epoxy coated on the inside. And where that's a nice feature is if you have a hydrant in the field that's 15, 20 years old, if you take our hydrant apart in the field, when you look inside of it, it looks almost brand new. That cuts down on a lot of the corrosion and a lot of the rust. It helps reduce head loss. It makes it very smooth and easy for the water to flow out. And it looks really impressive. Like I said, if you're working on a hydrant that's been in the field for 10 years and you open it up, it looks new on the inside. In addition to that, if you'll see on the right, also our inlet bases or shoes, we actually fusion bonded epoxy coat those like a gate valve. At one point, I thought that most everybody else in the industry did it, but they don't. Some people leave it bare metal. Some people paint the inside of it. And what happens, you'll get deposits on the inside. It'll start to rust and corrode. Ours is like a gate valve to ensure long life, easier maintenance. And I want to say probably another, sometimes it's the little things that make a difference. Our Zerk fitting or a plug on our fire hydrants for lubrication, which is critically important for maintaining a hydrant, we allow you to use either oil or grease. We don't say you have to use one or the other. If you want an oil-filled hydrant, you'll see like the bonnet on the right has a plug. Or if you want grease, food-grade grease, we have a Zerk fitting, the hydrant on the left. And you can see in the middle, really can't see my cursor moving here, but that plug or that Zerk fitting attaches to the same drain channel. It basically makes it easier for you to do maintenance on a fire hydrant. The easier for you to do maintenance on a fire hydrant means you'll probably maintain it a little bit easier. So if you use grease, you simply take our weather shield off, make sure that you unbolt it so it can breathe, and then you just hook up a grease gun to it, squirt it full of grease, and you're ready to go. If you're going to do maintenance and it's an oil, you just simply unplug the plug and pour oil in until it's filled. So I think those are the nicest, easiest features that I see just right off. I mean, again, we have so many features. Yeah.
Okay. Alrighty. Well, moving on here, we'll just real quickly talk, a reminder to everybody that's logged on today or listening. AVK's YouTube channel is American AVK, and you can see it here kind of in the center of the screen. American AVK is one word. And we've got a full suite of videos, learning burst, installation videos, and webinars on there. So I think that's important. And Ann should have a link to that in the chat as well. So if you have any questions about how to find it, definitely get a hold of me. And then moving on, Randy, I know you've put a lot of time into the development of the 5-bolt hydrant base. And if you could just talk a little bit about your extensive work on that and the benefits of the 5-bolt base.
Thanks, Kent. The 5-bolt inlet base was created in 2015 to solve several different issues that were reported from our customers from damaged hydrants that have been hit by a car and subsequently returned to AVK for review. And also changes were made from our own experiences here at the factory. The new 5-bolt design eliminated the ductile iron main valve flange that was originally sandwiched between the inlet base and the lower barrel. This change enabled us to improve the water flow so that we now have a 2.2 psi lower head loss when the hydrant is flowing at 2,000 gallons per minute. When an old style 4-bolt hydrant was installed in a sandy or loose soil, or even installed in a muddy area without a concrete collar at ground level, we noticed that when hit by a car, the unsupported hydrant would break off underground just above the main valve flange and not at the traffic flange as we expected. The new 5-bolt design has the lower barrel mounted in a shallow pocket located in the top of the inlet base. That, plus the added 5th bolt, significantly increased the strength of this joint so that the hydrant was more likely to break at the traffic flange instead of below ground. At the same time, the bolts below ground were changed to be 304 stainless steel as standard, and we included Teflon coated stainless steel hex nuts to prevent galling of the stainless steel fasteners. And of course, as an option, 316 stainless steel fasteners are available also with Teflon coated nuts. During field trips to visit customers and to inspect installed hydrants, I noticed that when contractors installed a hydrant extension kit, there were many times when the installer did not raise the 4-bolt traffic flange upward along with the 4-bolt nozzle section. The 4-bolt extension barrel kit had been fully installed into the hydrant assembly, but the traffic brake flange was left far below ground where it became non-functional in case of a collision with a car. To correct this issue, we began to supply the extension barrel kits with 2 5-bolt standpipe flanges. The 2 5-bolt flanges are used to attach the extension barrel to the top of the existing lower barrel. And since you cannot bolt a 5-bolt extension flange to a 4-bolt hydrant body, this arrangement forces the installer to raise the 4 breakable traffic flange upward along with the 4-bolt nozzle section of the hydrant. And as an added benefit, when we designed the 5-bolt inlet base, we included the anode lug onto the casting. The anode lug provides a spot to attach a grounding wire to reduce the effects of galvanic corrosion. This is in lieu of the aftermarket thermite weld-on blocks that can damage interior and exterior coatings and also damage the seats inside. You can see here in the photos on the screen, we have all the different various bases that are required by the customers in the field. We have flange, MJs, push-ons. We have it in 4-inch, also in the more common 6-inch sizes.
Okay. And then Randy, on the next screen here, I'm showing the Teflon coated nuts on the base bolts.
You can identify them by the blue color of the Teflon.
Mm-hmm. And that was primarily just to assure that with the stainless steel upgraded bolts, it wouldn't seize, correct?
That's correct. And also, if somebody had purchased a hydrant with a flanged base and then they later decided they wanted to convert it to an MJ, they could easily do that in the field with the Teflon coated nuts without risk of galling.
Okay. Well, John, Wilbur, I guess we'll move back to you and you can talk a little bit about additional improvements that you think are relevant. You're muted right now, by the way. Okay.
Let me back up a little bit. Mark Tompkins got called. This is in regard to the stem coupler. Mark Tompkins got called because he had a little bit of a slamming problem with one of his hydrants. And they got out there and took it apart, found this nice bent nail. It is a hydrant pin. So if you ever need to work on an AVK fire hydrant, please use AVK parts, not non-standard parts like this. If you call us early enough, we can get them out to you that day, FedEx overnight, and definitely by the next day. So along with the stainless steel upper stem, 1998 AVK offered the stainless steel lower stem as well, and that can be the 304 or 316 stainless steel. So the entire stem assembly from top to bottom, including the pins and the brake coupling, can be stainless steel for a truly corrosion resistant operating mechanism for the fire hydrant. And then next, I'm going to talk about all the different configurations we have. So on the left there, we have the 2780. And as you can see, it comes in the normal one one pumper, two hose. But we also have a double pumper, which is in the lower right, that orangish one, a single pumper and a single hose. Those were all added from 1998 to 2007. And then on the modern side, we have a modern double pumper, the traditional 3-outlet, a modern single pumper, and we also do a monitor hydrant in either a 3-inch or a 4-inch elbow. Once again, those were all added starting in 1998 and I think up through 2011. Along with all of the hydrant configurations, we also do a PE inlet base where we developed the Series 66 PE valve. This is a 4-inch PE inlet base. We also do a 6-inch as well, and we do those up through DR9 anyways, maybe DR7 occasionally. If you really ask for it, we can get it to work. And then the last one, we developed the HiMax Valve, which is available. The HiMax valve is available in HiMax by HiMax or HiMax by flange. In 2-inch up through 12-inch, we also developed a HiMax 6-inch inlet for the hydrant. So you can put those all in and have a 1-bolt restrained coupling.
And then that's also available on the Series 67 as a 2-inch, correct?
That is correct.
Yeah. So, all right. Well, I'll move back to Randy Looney here. And Randy, do you want to touch base on any additional improvements that you want to note to the audience?
Yeah, there's several I'd like to bring up. The thrust nut at the top of the hydrant was originally secured with a tiny single set screw that was drilled and threaded through the thrust nut threads between the thrust nut and the bonnet. This design did not allow for future adjustment of the gap between the thrust nut and the operating nut if either or both components had to be replaced. The added gap between components that you could not remove could later lead to a water hammer problem. Also, it was a bit difficult to keep track of that tiny set screw when working on a hydrant in the field. I myself accidentally dropped one in the dirt next to a hydrant that I never did find. The new stainless steel lock that was added to all hydrants in 1996 allows for fine adjustment of the thrust nut to prevent any excess space between the thrust nut and the operating nut. This ensures that the components will not contribute to a water hammer event. Then in late 1999, as you can see on the screen here, we added the Torrington Koyo roller thrust bearing as an option to the top of the operating nut to reduce the torque required to operate the hydrant, especially in areas that experience very high water system pressures. In late 2018, the roller bearing became standard in every Series 27 hydrant. Originally, our modern style hydrants were equipped with a 12-inch upper barrel or with a 30-inch upper barrel that was available as the only option. The 30-inch upper barrel, also known as our Alpine barrel, was created for areas that experience deep snow and wanted their hydrants to be taller and more accessible in wintertime. An 18-inch barrel was made available as an interim size between the two original sizes. Then later in 2015, as we entered the Dakotas and Minnesota markets, we added the 16 and 22-inch sizes, as these were the heights that were already in use and preferred by customers in these states. The next one is the traveling stop nut.
You can see, Randy, on your screen there, the where they've added the extension kit to try to raise the hydrant. That's one reason we decided to put these. Putting an extension kit there obviously did not work. So just wanted to mention that.
Right. The travel stop nut was revised in 2005 to be a thinner style. And this was done in order to increase the opening space between the main valve and the seat ring by a factor of 14%. This was done to reduce the head or friction losses, which results in increased water flow. As we all know, as water flow is increased, it reduces the amount of time required by the fire department to put out a fire. And then in early 2011, I believe, we began adding laser cut aluminum berry tags to every Series 27 hydrant. The tag is attached to the top of one of the traffic flange bolts, so it's easily visible when standing next to the hydrant. And the berry tag that we put on are the two larger ones that actually say berry. The smaller one is included in the extension kits that can be added to the original berry tag. So if you have two of these tags on the hydrant, for instance, you have a 5-foot 0-inch berry, and then you later add on a 6-inch extension, you'd have originally the tag that's in the center of the three on the screen, and then you'd add on the 6-inch on the bottom. So you'd add those two together to get your 5-foot 6-inch total berry.
Okay.
And
all right, Randy. Well, I guess I'll move on to what I consider to be my list. And obviously everybody touched on some really good ones, so that leaves me with a few of these. But at the top of the screen here, the new dry barrel hydrant operating wrench with the hex for the thrust nut located in the center of the wrench instead of on the end of it. And anybody that's worked with these, I think John Wilbur's the one that, you know, created this wrench here and moved that hex to the center. That is a huge thing. Also, right below the words lightweight toolkit, you'll see the little centering ring. And Randy, I don't know if you can elaborate on this, but I've always just said that basically what that does is assures that when you start to torque on that to remove the main valve, it keeps the torque centered on that stem and doesn't damage the coupling. Would that be fair?
That's pretty accurate. We originally developed it for customers in Canada and northern states where they have a lot deeper berries, and it gives them something to lean against with that tool when they're starting to really put a lot of force on it to unscrew the seat ring out of the drain ring.
Okay. And then another thing that I think was a significant improvement, even though it may not be as good as some of the others that were already mentioned, the pumper and the hose caps, when the strength of the cap was increased. And Randy, could you just tell them a little bit about why it is that we kind of do want the cap to be able to break, but of course, when you made it stronger, that also gave us some benefit.
When we originally designed that cap, on the inside underneath the operating nut, there was a dimple that was in the casting. The dimple really had no function, but it was there to probably reduce a little bit of weight in the casting. But then the issue became when we machined the outside of the cap just underneath the operating nut for the chain fastener. There's a groove that's cut there, and that fastener was crimped into the groove. Well, what we realized was that that machine groove coming very close to that dimple, and it was thinning out the wall too much. So if you put a lot of torque on that nut, sometimes it would break off. So the solution was just get rid of the dimple, and that solved the entire problem.
Yeah, thank you, Randy. I didn't mean to put you on the spot there, but I thought that was significant. And so I wanted to mention that. Probably next is going to be the fifth lug that was added to each of the nozzle recesses. And you can see that at the left of the screen there. So that did a number of things. Primarily, it would assure that you could not install the nozzle, whether it be a pumper nozzle or a hose nozzle, incorrectly. So you can see on the nozzle itself, it's got a recess there with the AVK letters in it, and that has to slide over that fifth lug on the inside of the raceway there. If you don't do that, all the other lugs are solid. Do you have anything to add on that, Randy, at all?
Well, we always want to make sure that the locking set screw lands in that split lug where you can see the little AVK logos, which is reversed in this photograph, by the way. And you can only rotate that nozzle about 40 degrees before it hits its stop. It won't rotate any farther than that. So to ensure that that split lug will always wind up with that locking set screw, we put the fifth lug on there so the nozzle can only go in one way, it can only rotate one way, and it always lines up with that locking set screw perfectly.
Okay. The next thing that I think is a significant improvement is we used to have one set screw to hold the nozzle in place. That's the one that Randy just mentioned that fits in that void there. However, we noticed that especially in areas where the hydrants were taller, a lot like what we showed earlier, some of these higher hydrants keeps the pumper or the hose nozzles up out of the snowdrift. We were seeing that if they put a hydrant meter on it and did not use a stand, which they're obviously supposed to do, it could put some pressure on that nozzle and possibly let some water get by that O-ring you see there on the left. So Randy did a very nice job of installing a second set screw at about, I would say, 9, and you can see it there on the right of your screen. The first photo in the middle is covered, and Randy can talk about that a little bit. We cover it up and then we actually paint over it. Randy, do you want to explain the significance of that? And what the audience needs to understand is the reason we paint over it is one thing it shows as if it's been tampered with. So go ahead, Randy, if you got anything to add.
That's correct. It was covered over. There's a little piece of foil in there that covers the socket of the set screw. Then we put like a body filler to smooth it out. And then it's painted over the top, and it's strictly for security too. So somebody doesn't come up, it takes them quite a bit longer to try to figure out how to get the nozzle out. Those people that work on them all the time are aware of it, but somebody that wouldn't be aware of it would have a very difficult time removing the nozzle unauthorized.
Yeah. Okay. Moving on, I don't have an image of this, but on the inlet base of the hydrant itself, the adding of the anti-rotation lugs for the T-bolts, I think, was a significant improvement made to the hydrant, and that was done in 2015. And then a lot of people that are on today may not have seen this before, but we started in December of 2015 offering a straight 5-bolt inlet base, primarily for Ontario, Canada. And, you know, we offered that with lower extension barrels as well. And Randy, can you kind of explain a little bit about why a utility might want to use the straight inlet instead of a standard connection?
This is mostly for industrial installations where the hydrant is going to be mounted right on top of a T, usually inside of a large warehouse building or other large structure where it's protected from freezing. It just, if you're going to have shallow pipelines, it makes it easy to mount it onto the shallow bury pipeline.
Okay. Another improvement I have listed here is the grease lubricant being changed for better lubrication. The new grease is still NSF H1 food grade, kosher approved, but it also assures you know, it doesn't contain any acetates for corrosion resistance and no silicone, so that it can be repainted. I think that's a significant improvement. And then one that anybody's dealt with AVK might be very pleased to see was October of 2011, we eliminated what you see here on the tailgate of this truck, which we called a spider. We had been using them since January of 1995 to support the stem and hydrants 6.5 foot and deeper bury. We had had a few issues on extension kits, however, where the operator might over tighten that bolt that you see there. And when they would over tighten it, it would actually possibly tear or put pressure on that rubber spider and later cause some damage. And so we just went ahead and eliminated that feature. And then moving on, I think my last items would be the 4-inch stores pumper, nozzle and cap became available in late 97. And then a 5-inch stores nozzle and cap in 2002. And then adapters for stores with caps would fit any type of hydrant became available in 2005. And then in 2009, we did the stores 2.5 inch. And in February of 2010, the 5-inch stores for large diameter hose, because after 9/11, almost every new fire truck had large diameter hose, and the 5-inch NST allowed them to have that with no adapter. And so that's kind of it for today.
We got one more Kent we forgot to mention.
What's that?
I'll just go back a little bit. So AVK will also offer for new installations, if you want to stop the chance of cross-contamination or somebody contaminating the drinking water system through a fire hydrant, we do offer a check valve, which is designed to fit any manufacturer's MJ bell and goes at the inlet to the fire hydrant.
Yep, I think we're shipping about 80 of those, or we did last week anyway, into a site in the southeast. So anyway, good point there. And then moving on to the end of this thing, I did want to make everybody aware, if you have any ideas or suggestions for Tailgate Talk, or you want to sit in and talk about something that's happened in your market, obviously what we do provide to the people that are at the show, the Tailgate Talk hat and a polo shirt.